Oops, clicked the wrong background. There we go, ready to go. Okay, we are on to our last unit of this quarter/semester. Remember, guys, all this stuff we've learned so far, in a normal year, you would have learned from August to December. So we're already halfway through the school year and all the content we have to learn technically. So let's go ahead and get going with this. So I really like this unit. This is called Transformations. It's actually not very difficult. It's a very visual unit, even more so I would say than other things in geometry. And I hope if you have your notes, this is going to reference things in that notes. If you don't have them yet, that's okay. You can still follow along and just copy it down. So some of this vocabulary is at the top of your notes packet, though I haven't listed all of it, just kind of the important things. So a transformation, what that is, on the notes packet, it says an operation that maps a pre-image onto the image. Now that sounds kind of fancy. So if you want to also copy down what I call in layman's terms, that just means like in easy people terms that aren't math people typically. A transformation is something that moves or scales an image. So you guys know, like when you upload photos, you can scale them. You can make them bigger or smaller. That's also a transformation. But if I also want to move something, or if I want to flip something, or if I want to rotate something, that's also a transformation. Moves or scales it, changes the size. Now, to start off with, we're going to talk about isometries. This is, again, what it says on your notes packet. If you don't have your notes packet, copy this stuff down. An isometry is a transformation that keeps the same lengths and angle measures from each shape to the new shape, from the pre-image to the image. That's what it means by pre-image to image, the original shape to the new shape. Now, what this means is any transformations that are isometries create congruent shapes. So, looking at the type of isometries, this will make a bit more sense. So, a reflection, if I have a thing here and I reflect it, what I'm really doing is I am flipping this. I meant to write this in. A reflection is what we can also call a flip. It's like I'm flipping over a mirror. Now, a rotation also, again, just turns the object. So a rotation, we call that, how did I say it in here? A rotation, we just say a turn. Yeah, good. And a translation just means I'm like doing this. I'm translating the object. Yeah, we call this a slide also. So we can say reflection, rotation, translation, or we can say a flip, a turn, a slide. Now, if you notice, all of those things I just did, I still ended up with the same shape. I didn't actually change the size or anything about the shape. I just moved it. I flipped it, or I turned it, or I slid it. These are all called isometries because they don't actually change the shape. Our last lesson, we're going to learn about something called a dilation, which does actually change the shape, but it's not an isometry. So again, you have all this stuff at the top of your notes packet. If you don't have your notes packet yet, make sure you have that all copied down. So to start off with, it's going to be super easy, especially if you do have the notes packet. So I want to point something out here. These numbers, example 1, example 4, example 7, refer to the example numbers in the packet. I kind of skipped around a little bit. As well as that, if you do have the notes packet, there was a little mistake with it. The answers are there. This was kind of a mistake. So hopefully you don't have the notes packet so that you can think for yourself, but the answers are actually on the notes packet for this lesson. But oh well, that's okay. So this again, example 1 and example 4, example 7 refers to different examples in this lesson in the packet. So what we're going to be doing is determining, is it a reflection, rotation, or translation? So this is just visually. Remember, this means a flip or a turn or slide. So let's look at the first one. Now, if we notice here, this kind of tells us the direction of the motion. We're moving it over, and if you notice, the shape is still oriented the same way, right? All I did was this. The face is still kind of pointing the same direction, right? So what do you think this is going to be? A flip, a turn, or a slide? This is a slide. This one would be a translation. All we did was we just went and slid the object. Nothing else changed. It was still facing up the same direction. I didn't go like this or anything. I didn't turn the shape. That's a translation. Looking at example 4 now. So again, in your packet, this is example 4. It's on the next page. Looking at this one now, we have this line here. We have our pre-image, and then our image is our second shape. So this is our first shape again. This is our second shape. What does this look like? Does it look like it was slid, flipped, or turned? Now this one's kind of tricky because this is new, but hopefully you guessed that this is flipped. This is a reflection. You guys should know that when you look at yourself in the mirror, it's a flipped version of yourself, right? It's not the exact same, it's flipped, right? That's why if you look in a mirror, anything with words on it, if you have a shirt with words on it, it's read backwards, right? So all this did was it was flipped over that line. That's why this line is here. That's our mirror flipping over it. So for the last one here, we have this little dot. Now, sometimes they do this because that's kind of where we are centering our transformation. So I'll give this one to you because this almost looks like a reflection, but it's not. This one is actually a rotation. Whoops, rotation. And here's why. This is like the center of our rotation. If we could imagine we tied a string to our pre-image and then we just swung the string around. Yeah, I could swing this string around to here, and that's my rotation. And again, another way to see this, let me see if I can do this right. That's going to be kind of tricky. Notice I'm going to turn this image and I'm going to end up in the exact same spot, just image and pre-image are going to be upside down. So here's my rotation. Hey, look, that's the exact same spot I was in. This is actually what we call a 180-degree rotation. We're going to learn more about that later. So notice my smiley face is up here. I'm going to rotate again. Hey, look, my smiley face is back up there. This is a rotation. If you see that little dot, a little dot means that's the center we rotate around. A line like this means we're flipping over it. An arrow means we're sliding. That's how we can also tell the difference between these. So let's go ahead and I'm going to have you try these ones. Again, example 5 refers to example 5 in the packet. Example 9 refers to example 9, so forth and so on. That's why they're numbered kind of weird. So look at the first one. I want you to say if this is a rotation or a flexion or a translation. What do you think? This is a reflection, like I just gave you guys a hint on the last slide. If you just have a straight line like this, that's our mirror. We are flipping over. We took that heart and we flipped it down. Yeah, this is a reflection. Okay, looking at example 9 now. So what do we think for this one? Reflection, rotation, or translation? What do you think? This is a rotation. We can see here a bit more clearly. They are rotating about this point, and here's that curved line telling us they rotated it down. That is a turn, that is a rotation. And last one, example 2. What do we think for this one? Reflection, rotation, or translation? Translation. That arrow tells us we just slid it over, right? I'm just taking my image and I'm going and sliding it down. That's a translation. So we are going to start with translations first because they're actually really easy to do. We're going to work more on translations in class, but I do want you to copy this stuff down. Because this is not in the notes packet. So if you have the notes packet, what you can do is turn to the page where you see example 10 or 11. Sorry, 10 through 11 and 12. Down at the bottom there, you have some space. Go ahead and copy this stuff. And we're going to be doing those problems, 10, 11, 12, 13, in class tomorrow. So there's different types of notations. Again, this is for translations. You will see it either like this or like this. Make sure you have those copied down. and then we'll go on. Now, I do want you to copy this thing as well. In each case, either this first notation or this second notation, the first number given, so in both cases, here's the first number, tells us which way to move each point in the x direction. Because this is a translation. I'm sliding something. That first number tells me which way to move in the x direction. Which way is the x direction? Left or right? Left or right is the x direction. So first number is left or right. So the second number tells us which way to move in the y direction, which is obviously the other way, up and down. So here's my first number. Here's my second number. Again, you might be given a different notation. Oh, oops, sorry, up or down. But the first number always tells us which way to move left or right. Second number always tells us which way to move up or down. We're going to work more with that in class tomorrow, but I just want you to have that copied down and ready to go. We're going to continue on with this stuff in class.